Hello and welcome to this R tutorial. So in the previous tutorials we took care of the pre-processing phase and then we applied PCA on our dataset to reduce its dimensionality down to 2 new extracted features, and now we are ready to build a classification model. So speaking of classification model, we started with a logistic regression model, but actually from this point we can build any classification model among all the classification models we made in part 3. If I go back to part 3 classification, this folder here, you have here all the models we made in this part 3, and basically from this point you can build any model you want by just selecting your classification model. For example, let's take support vector machine classification model. Then you can just open the SVMR file, and then basically all you need to do is take everything after the data preprocessing phase, that is from where you start to build your SVM model, and select everything down to the bottom and copy, and then in your PCA file you can include your classification model right after applying PCA on your dataset. And so here I just replaced the logistic regression model by the SVM model, and you can do this for any classification model you want among the classification models we made in part 3. So that's very easy to replace your different models by this simple copy-paste so that you can try different classification models very efficiently. So let's see what we get with this SVM model. For example, we just need to change here the name of the dependent variable. This is not purchased but customer segment. Here we go. And that's the only thing we need to change, because the data here has input training set, and this is the training set we just transformed, the new training set composed of the new extracted features. And so basically we are ready to select this section and execute it to build our SVM classification model. And now that the model is built, we are ready to predict the new observations of the test set. And so this line is ready. And actually we don't need to change anything because this index 3 here is the index of the dependent variable. And since we reduced the dimensionality of our data set down to 2, that means that we have 2 features and 1 dependent variable, and therefore the index of the dependent variable is still 3. And so we are ready to select this line and execute. And now we have the predictions of the test set results. So we can have a look, ypred in the console, press enter. And for each observation of the test set, we have its prediction by the model, the SVM model. So for example, the 4th wine of the data set that belongs to the test set is predicted to belong to customer number 1, and the wine number 132 is predicted to belong to customer segment number 3. So very easy, and now we can make the confusion matrix, and same, we don't need to change anything here because this corresponds to the index of the dependent variable. So we are ready to execute this as well. Execute. The confusion matrix is ready. Let's have a look. And wow, perfect results. We only get correct predictions. As you can see, 12 wines were correctly predicted to belong to customer segment number 1, 14 wines were correctly predicted to belong to customer segment number 2, and 10 wines were correctly predicted to belong to customer segment number 3. And then we have 0 incorrect predictions. So these are excellent results, and of course we get 100% accuracy. So now when moving on to the next part to visualize the training set results, we should get amazingly well separated prediction regions and a very clear prediction boundary. So let's check it out. But now we have something to change, and this is not a tiny change as we used to do, because now we have 3 classes. And as you can notice in this code, when we plot the prediction regions thanks to this line, well, this code template allows us to do it when we only have 2 classes. Because as you can see, we have this if-else condition. If y_grid equals 1, then the color is green, and else if y_grid equals 0, then the color is tomato. And same when we plot the observations. If the observations of the set, that is the training set, belongs to class 1, then it's a green, and if it belongs to class 0, that is in the else condition, the point will be red. But now the problem is that we have 3 classes. So we need to improve this code here to distinct the three conditions if y equals 0, if y equals 1, and if y equals 2. So let's do it. That will be good coding practice. And speaking of coding practice, what would be very good is that you try to do it before I do it in this tutorial. So you can press pause and try, and now I'm gonna do it. So basically we need to add one more condition, the condition where y equals 2. So let's do it. Let's add this new condition here. If y grid equals 2, then comma, and then after this condition y grid is equal to 2, we will put what we want. And what we want is a new color, because there is one color associated to each value of y grid. So we will keep spring green 3 for the case where y grid equals 1, and we will keep tomato for the case where y grid equals 0. But for y grid equals 2, we need to introduce a new color, and since we have here green and red, let's put blue. So a good color is actually deep sky blue, then comma to get the next conditions. So far what we see is that if y grid equals 2, then the color will be deep sky blue. Then if y grid equals 1, then the color will be green. And if y grid equals 0, then the color will be red. But this is not how it works. It's not as simple as that, because this is actually not a correct syntax, because this if-else function expects 3 arguments. The first argument is the condition, y grid equals 1. Then the second argument is the result when this condition is true. And the third argument is the result when this condition is not true. So here we have a lot more than 3 arguments, so that's not right. And so the trick to solve this is to put all this, that is the y grid equals 1 condition, and then the result spring green 3, and then the result if y grid equals 0, into the third argument of this if-else function. So that means that we'll get the first argument y grid equals 2, that's the condition. Then the second argument deep sky blue, that is the result when y grid equals 2. And the third argument, all this in one same argument. And so how can we include all this in one same argument? Well, we need to use another if-else here, which will contain the other 2 conditions, where y grid equals 1 and y grid equals 0. And so we need to be careful with the parenthesis, because we added a new function, this new function if-else, and here it is. The new parenthesis is added, and now it should be fine. So let's recap. We start with this first if-else here. So if y grid equals 2, then the color will be deep sky blue. And then if y grid is not equal to 2, then we go into this new if-else. And this new if-else contains the 2 last remaining conditions. That is, if y grid equals 1, then the color will be spring green 3. And if y grid equals 0, then the color will be tomato, like red. And therefore we get our 3 conditions in the correct syntax. So that's a trick. It's actually quite common to do it in coding, so it's good to know how to do it. And that's the same to plot the colors of our observation points. So we need to take this and paste it here again, and then replace this 1 here by 2. So that is the new first condition. If our observation point belongs to class 2, then we want to give it a new color, which will be a blue color, but a different blue than this deep sky blue. And so, we need to get a good contrast so that we don't confuse the color of the point and the color of the region. So actually a good color to use here is blue 3. Blue 3, you'll see that it will give us a good contrast. And so that's the first result of the first condition. And then same, we need to include the 2 remaining conditions here into one argument that is inside a new if-else. So if-else here, and parenthesis, and we don't forget to add the closing parenthesis here. And here we go, this is ready. So recap again, if our observation point belongs to class 2, then it will have the color blue 3. Then if it doesn't belong to class 2, then we go here, and here we have two new separate conditions. If our observation points belongs to class 1, then it will have the color green 4, and if it doesn't belong to class 1, then it will have the color red 3. So that should be ready, and then we have the tiny changes to add. So remember, in this line here, line 49 with the column names, we need to input the real column names of the columns of the training set. And these column names are not age and estimated salary. That was for the previous classification problem. Now the column names are, of course, PC1 and PC2. So here we just need to replace age by PC1 and estimated salary by PC2. So that's compulsory. That's actually what you need to input. Otherwise you will get an error when you execute your code. And then here that's not compulsory, but it's better for the visualization. You can replace age by PC1 and estimated salary by PC2. But if you don't do it, you will not get an error, because this is just for the visualization. This is just for the labels that you will see on the graph. All right, and then I think we're good. I think this is ready to be executed. Let's hope that I didn't make any mistake. So we're gonna try to execute this and let's see what we get. So I'm going to select everything in this section. So from here up to the top here, and let's execute. All right, good start. It's running. Let's see what we get. Let's go into this plot tab. It is still running. And here we go, we get our beautiful results. So I hope you like my choice of the colors. This is the deep sky blue, and this is the blue 3, so that we get the contrast between the observation points and the prediction regions. So we can actually enlarge this if you want. So as a quick reminder, the points are the real observation points. That is, these are the wines that we have in our training set. And the regions are where our model predicts that the wines belong to the customer segment. So for example, the green points are the wines of the training set belonging to customer segment number 2. And this green region here is where the model predicts that the wines belong to customer segment number 2. And same for the blue and red parts here. All right, so now we can quickly do the same for the test set. So we actually need to do the same changes as we did for the training set. That is, let's start with the simplest one. We need to replace here age by PC1, estimated salary by PC2. So these are compulsory changes, and we can also change the labels even if that's not compulsory changes. Replace age by PC1, replace estimated salary by PC2. And here we go, we are almost ready. We need to make this big change here to add the third condition, to add the third color. And we can actually take these two lines here, copy them, and select this and paste. All right, we can do this because these are the same variable names as for the training set, because we use this set variable name here for both the training set and the test set. And so basically that's ready. We can now select this whole section here and execute to visualize the test set results. So let's do it. Here we go, it's processing. The test set results are coming, and we should get a perfect plot with no incorrect predictions. That means that we should get all the green points in the green region, all the red points, where here we go, all the red points, as you can see, are in the red region, and all the blue points in the blue region. So that's perfect. That's a perfect representation of 100% accuracy. And so in conclusion, we were able to transform a data set composed of 13 independent variables into this new data set of reduced dimension. We were able to reduce the dimension down to 2, thanks to which we could visualize the results in 2 dimensions. Okay, perfect. We are done with this first section about PCA. And now the interesting thing that we want to see is how our next dimensionality reduction technique that we are going to implement is going to do on this dataset. This next dimensionality reduction technique is LDA, linear discriminant analysis. So we'll find out about that in the next section, and